Okay, we're going to use a product rule on this. That's what instructions tell us to do. So let me get rid of the radicals. So the square root of z I'll rewrite as z to the 1/2 power minus 5. And same here. This will be z to the 1/2 power. Everything else carries down. Now this is going to be p, and this will be q. So for our product rule, we need p prime. The derivative of 3z is 3. Now for this one, I have 4, and I'll take my power, put it out in front, and then I'll lower my power by 1. And a minus 5 drops away. It gives us 3. 4 times 1/2 is 2. Z. 1/2 minus 1 is negative 1/2. And we never want negative exponents, and well, I shouldn't say never, but typically we never want them unless the problem indicates otherwise. So how I get rid of that negative exponent, I take the z to the negative 1/2 to the denominator. And this can actually be simplified a little bit more, but we'll leave it that way for now. Take the derivative of this. 2 stays there. Take my power, put it on front, lower it by 1. And the 5 drops away. So q prime. Those cancel. And we got z to the negative 1/2. Take that down below, and we got 1 over z to the positive 1/2. Again, negative exponents you always take down to the denominator. Okay, so we got p prime q plus p q prime. That's our product rule. So for f prime, we're going to have p prime, which is 3 plus 2 over z to the 1/2, times q, which is 2z to the 1/2, plus 5, plus p, which is 3z plus 4z to the 1/2, minus 5, times q prime, which is 1 over z to the 1/2. Now this is going to be fairly simple to work with there, but this one, yeah, I'll go ahead and multiply these together and see what happens. What my thought was is, do I need to get a single fraction in this, if this would help me. Yeah, I think it would. Let me get a single fraction there. So 3 is the same as 3 over 1. And I need to get a common denominator, which is z to the 1/2. So I multiply the top and bottom by z to the 1/2. So I got 3z to the 1/2 over z to the 1/2 plus 2 over z to the 1/2. Everything else carries down. Now here I'll go ahead and put this into a single fraction. So we've got 3z plus 4z to the 1/2 minus 5 z to the 1/2. Now here this becomes 3z to the 1/2 plus 2 over z to the 1/2 times 2z to the 1/2 plus 5 plus 3z plus 4z to the 1/2 minus 5 z to the 1/2. Now this is the same as being over 1, which means I'll multiply the top parts together and multiply the bottom parts together. 3z to the 1/2 times 2z to the 1/2. 3 times 2 is 6. And if you got z to a power times z to the power, you add the exponents. 1/2 plus 1/2 is 2/2 or 1. I'm just foiling. 3z to the 1/2 times 5 is 15. Z to the 1/2. 2 times 2z to the 1/2 is 4. Z to the 1/2. 2 times 5 is 10. All over z to the 1/2. And this carries along. Now I'm going to, they both have the same denominator now, so I'm going to add together the top parts. I got a 6z here and I got a 3z here. 6z plus 3z is 9z. I got a one half here power. I got a 1/2 power here and a 1/2 power here. 15 plus 4 is 19. Plus another 4 is 23. So we got 23z to the 1/2. Oops, why am I making that smaller? Let's try it again. 23z to the 1/2. And number wise, I got 10 minus 5, which is 5. Z to the 1/2. Now, typically, simplified form means get a single fraction. But if we look at what answer they're looking for, they actually split it up. So they're not very consistent in that regard. So if I split this up into separate fractions, the pluses up here is what separates them. So this is 9z over z to the 1/2 plus 23z to the 1/2 over z to the 1/2 plus 5 over z to the 1/2. Now this is z is same as z to the first. So we got z to a power over z to a power. So you subtract smaller exponent from the larger one. 1 minus 1/2 is 1/2. So this becomes 9z to the 1/2. Here the z to the 1/2s cancel and I got 23. And do they leave that down denominator? Yes they do. 5z to the 1/2. Last thing we'll do is change those z to the 1/2s to square roots. So this is 9 square root of z plus 23 plus 5 over square root of z. And that's where they get their answer at. They reverse these. I won't finish that step though.